Generative Adversarial Networks, or GANs, as they are often called for short. This was perhaps the most significant development in recent years in the world of image synthesis. The generative adversarial networks go well beyond the capacity of deep dream. They are much more precise in the way they operate, and they can operate in much higher definition. And they are the brainchild of this guy, Ian Goodfellow. Um, the rumor is that the story is that he was in a pub one night and suddenly this idea came to him and he worked feverishly overnight and developed this thing that we now know as generative adversarial networks. Whatever the case is, it's absolutely clear that GANs have had a major, major impact on the world of art and increasingly also on the world of architecture. So how does a GAN operate? The GAN is based on the principle that there are two neural networks that are competing with one another, hence generative adversarial network, the name itself. One of them is a generator that is producing images, and one is a discriminator that is deciding on whether that image is good enough. One could think about this in terms of an artist or a critic, or even better, in terms of somebody who is trying to fake, let's say, a Van Gogh painting, and a critic who can tell you whether or not it is a convincing Van Gogh painting, because that essentially is what is happening in the process. So here you have one neural network, which is the generator, and one that is the discriminator. The neural network, the generator, is feeding off random noise, and out of that, it is producing a fake image. Now, the discriminator is then comparing that image to a data set on which it has been trained and deciding whether it is convincing or not. So it decides whether it's real or whether it's a fake. And to some extent, the discriminator could also, as it were, give some hints. Well, it's getting closer, it's getting closer. And this is what allows the generator to refine its production until it gets to the point that the discriminator is convinced that this is a real image by comparing it against the data set. This is actually very similar to the notion of a Turing test, whereby you test to see whether you're convinced whether a computer is human or not. In the middle, there is somebody who is judging and comparing a human being on the left-hand side to AI on the right-hand side, and whether or not deciding whether or not that person is convinced about whether that AI is human. The Turing test is devised to see whether AI can be convincing enough to persuade someone that it's human. And what's been happening with GANs is, of course, there's a whole zoo of GANs, many, many different types of GANs, and they've been getting progressively better and better. Much of the early work was done using images of faces, partly because there are many of them available on the internet, and partly also because faces are broadly symmetrical and therefore lend themselves to this. But of course, you could work with other images. This is an image of an interior of a house, and so on. The GANs of over the years have been developing, it's only been since 2014. Over the years, there have been a series of different GANs that have got progressively better and better, starting off with progressive GANs, for example, and then more recent version, style GANs, was one that managed to achieve something which is described as being avoiding the entanglement between different layers, so you can begin to therefore get more refined in terms of the process. So style GANs has been, which now is the second version of style GANs, was really quite a breakthrough in terms of producing these astonishing images. These are images of people who do not yet exist, and they are generated based on a vast data set of images, and it's interpolating between those images. In other words, giving you a kind of blend of different sort of images, but each one of these is different, is novel. And as a result, there is a website you can go to called This Person Does Not Exist, and every time you refresh the browser, you will get another face, pretty convincing in how it operates. These are some of the images that I produced myself on that website. You can see there are certain glitches some telltale glitches, but with time, eventually the system gets better and better. And this is what happens with deep learning. Hence, apps that translate language get increasingly good at translating languages. And you would be I mean, this is very convincing. You would be absolutely convinced that these are faces of individual people, of real people, but they're not. And of course, this opens up the possibility of fakes, which itself becomes another kind of issue. Within an architectural arena, increasingly architects are using this as a way of kind of hallucinating forms out of the computer. This is the work of StyleGANs. This is using StyleGANs. It's the work of Ligier, one of my students from Brazil at FIU, Florida International University, where she's working actually here with landscape and hallucinating different forms of landscapes. It's in a way what it's very suggestive in the sense it can become like a muse that will inspire you by producing all sorts of different ways of forms. This is another study of using style GANs that was produced by another FIU student of mine, Maria, where she's looking at the taking images from the Grand Canyon from a grotto there and hallucinating other possible images. And you can see that in many ways it can be quite convincing. The work of Mario, also from my same design studio at FIU, where again he's hallucinating forms out of this. The problem with this? Well, the problem is that actually they're only two-dimensional images. You can get to the point where you can begin to hallucinate entire buildings, and this is the work of Wan Yu He, one of the Doctor of Design candidates at FIU, who is the principal of XCool, one of the leading companies for developing AI for architecture, based in Shenzhen in China. And this is her version or their version of this person does not exist. This building does not exist. And in fact, for a while, their company hosted a website, This Building Does Not Exist, where you could literally hallucinate these buildings. So they might look as though they're three-dimensional buildings, but in fact they are just two-dimensional buildings. But what one can see immediately here is the potential for AI to generate novel buildings. Obviously, in this case, in the case of style GANs, it's going to be based on the input of what you put in, which in this case is a data set of thousands of images, and it can only interpolate images based on that data set. But if you were to pair it with another data set, and this happens with cycle GANs, for example, you can begin to breed other novel versions that are quite unlike the original data set. So all of a sudden, we can see that the techniques developed using for developing faces can also be used to architecture to hallucinate other possible architectures. This is a very significant step in the application of AI to architecture.